Welcome to Unit 9 Probability. This is Day 3 Mutually Exclusive Events. We're actually going to start this off by talking about mutually exclusive groups. On this first problem, we're going to have 23 students in a class, and they are all either members of band, chorus, or both band and chorus. So the band and chorus is, in this context, not mutually exclusive groups, because some people could be members of both of the groups. There are 15 band members in the class and 12 chorus members. How many students are members of both band and chorus? So if I were to make a Venn diagram, is how I usually think of doing these things. If there's evidently, I'm going to make the red over here the band and the purple the chorus. If evidently I have, it says 15 band members and 12 chorus members, and I'm only got 23 altogether, well, 15 plus 12 is 27. And that must mean that there's 4 people that are in both band and chorus, meaning that there's only 11 students that are only band members and 8 students that are only chorus members. But my answer for this problem would be the 4 members that are in both that made that overlap. So these two groups are an example of when groups are not mutually exclusive. Here the band and chorus was not mutually exclusive groups. An example of mutually exclusive groups would be South Caldwell High School freshmen and seniors. There is no student who's a freshman and a senior at the same time. So those two groups have no overlap. Mutually exclusive events are events that cannot happen at the same time. You'll definitely want that in your notes. All right, taking a look at example 1 here, just figuring out whether these events are mutually exclusive or not. Han draws 1 card from a standard deck. Determine whether drawing an ace or a 9 is mutually exclusive or not mutually exclusive. This is mutually exclusive, and I'll actually get into why. It's because there is no card that is both a 9 and an ace. The groups of cards that are 9 are completely separate from the groups of cards that are aces. So these are mutually exclusive groups. Now, looking at part B, Han draws 1 card from a standard deck. Determine whether drawing a king or a club is mutually exclusive or not mutually exclusive. This one is not mutually exclusive, and the reason is the king of hearts, or excuse me, a king of clubs. The king of clubs, that 1 card is both a king and it's a club. So because of that, the two groups have overlap, and they are not mutually exclusive. For our next problem, and you're going to want to get what's in the blue box there. You're going to see what happens with mutually exclusive events when there is no overlap. It's pretty straightforward. You're going to see the word "or" used in these problems, and that's a union. When you see that, you're going to add the 2 probabilities together. You're going to have 2 events. Trevor reaches into a can that contains 30 quarters, 25 dimes, 40 nickels, and 15 pennies. What is the probability that the first coin he picks is a quarter or a penny? Now, we're figuring that each of these is equally likely, that the size is not impacting his probabilities. The probability that he picks a quarter or a penny, let's deal with the quarter first. And by the way, these are mutually exclusive events because there is no quarter that is also a penny, or vice versa. So they are 2 completely separate groups. So for the quarter, there are 30 quarters out of 110 total coins. And I got that from the information they gave me, 30 quarters, and I added these numbers to get the denominator. Now I'm going to add to that for my other event because it said the word "or." Now, the denominator will not change. He's only picking 1 coin. He's not picking a coin and not replacing or anything like that. So he's only doing this action once. The groups are mutually exclusive, so let's take a look. The pennies, there are 15 of them. And so that's how I set this up, quarter or penny. And that means that there's 45 total coins that he gets a favorable outcome out of 110 total coins. And this is my answer. as a percent, it would be 40.9%. And I did round to the nearest tenth of a percent, as y'all have seen me doing throughout this unit. Now, when the events are not mutually exclusive, when there is that overlap, what you have to do is you'll still add the two probabilities together, but you'll subtract away the intersection just once. All right? And you'll see that now. So this is using a table here, and we're trying to find the probability selects a watercolor or a landscape. I'm going to go ahead and add these things up real quick. So to help myself out, I added up each of the rows and each of the columns. Now I'm wanting the probability that he selects a watercolor or a landscape. So let's take a look at watercolor really quick. I'm going to use 12 out of 30 possible. So 12 over 30. I'm going to add to that landscape, which is 11 out of 30. But if I stopped right here, I'd get the incorrect answer. And the reason is because there are some paintings that are landscape and watercolor. So what happened here is these three were in both of these. So it got counted twice. I have to subtract it out one time to account for that. And what I'll get is 12 plus 11 is 23. Subtract away the 3 is 20 out of 30. This is 2/3. And I'll use 33.3%. Now, what you could have done instead is you could have done 4 plus 5 plus 3 is 12, plus 2 is 14, plus 1 is 15, plus 5 is 20, 20 out of 30. By doing that method, I didn't count the landscape watercolors twice. I only counted them once in doing that, and I get the correct answer. But this is the process we got to do, folks. We've got to subtract it back out if you do count it twice right here. So what is the probability of drawing a king or a diamond from a standard deck of 52 cards? What you're going to see right there is for the king, there are 4 kings in the 52 cards. I'm going to add to that the diamonds, and the diamonds account for 13 of the 52 cards. Remember, there's 4 suits in the 52 cards. There's 13 in each suit. Now, the problem here is the king of diamonds was here. It was also here. I have to subtract it once back out, so minus 1 out of 52, because those groups are not mutually exclusive. There is a king of diamonds that is both a king and a diamond. And now I'll be able to get my answer. So I've got 4 plus 13 is 17, minus 1 is 16 out of 52. That is 4/13. And if I type that in my calculator, I get 0.3076. So I'm going to write that as 30.8%. And I've got my answer. Sometimes what's called a complement of an event can actually help you a great deal. For instance, if you had a probability of an event, to find the probability of that event not happening, you will take 100%, and take away that probability. So in this example, Sergio brought the raffle tickets to calculate his probability of winning. It would simply be the 18 out of 150. But what the question's asking for is, what's the probability he will not win? So now that I've got the probability that he will win, it will be its complement, because those two probabilities would have to add to 100. So for him to not win, that would be 1 minus 18 over 150. And I get 22/25, which is, as a percent, 88% that he will not win. He had a 12% chance of winning, so he has an 88% chance of not winning. It always has to add to 100%, which is the number 1. Just keep that in mind. It is useful to use a complement at times depending on your situation. That wraps up today. Appreciate it very much. Make sure you get done with your homework.